Hi, this is Babak. In this video I'm going to solve the following problem for you. Evaluate the following integral. I equals to integral of sine inverse of a square root of x over square root of 1 plus x dx. I recommend you to pause the video at this point and try to solve the problem yourself first. The answer to this integral can be written in the following form. 1 plus x times tangent inverse of a square root of x minus a square root of x plus c, the constant of integration. Okay, let us now solve the problem. One thing that I want to mention, because I want to do a change of variable here, but I want to make sure about the domain of this function which is involved here. So I'm claiming that x greater than 0 is the domain of it's greater than or equal to 0 is the domain of this function. So what I'm trying to say is that the domain of this function is the interval of 0 and infinity. Okay, it's clear because if x is non-negative, 1 plus x is also non-negative, so it's actually positive. So then this is defined. It is defined and it is clear that it is between 1 and 0. Okay, so this means that sine inverse is also defined. So if x is greater than or equal to 0, this function is defined. But if x is negative, square root of x is not defined, so the whole function is not defined. So this means that the domain of the function, if I call this function f of x, then the domain of that function is this interval. Okay, now after a few number of trials and error, I was able to find an appropriate change of variables here. So what I define is here, I would say let theta be equal to tangent inverse of a square root of x. Okay, so because we know that tangent inverse in general is between minus pi over 2 and pi over 2, and then because the square root of x is positive, so you immediately realize that tangent of theta is the square root of x, and then you can also conclude that theta is a number between 0 and pi over 2. And from here, of course, if you calculate x becomes tangent square of theta, and I know that theta is somewhere between 0 and pi over 2. Okay? Here I need d of x, so x is equal to tangent squared of theta, so this gives me dx is equal to 2 tangent theta. The derivative of tangent theta is secant squared theta d theta. Okay? And then what happens to my square root of x divided by square root of 1 plus x? This becomes tangent theta divided by square root of 1 plus tangent squared theta. Yes, so instead of square root of x, I put tangent of theta, and instead of x, I put tangent squared theta. But then this becomes equal to tangent theta, and then I have square root of 1 plus tangent squared is secant squared, so this becomes tangent of theta divided by the absolute value of secant of theta. But because theta is in the first quadrant, secant theta is positive actually, so I don't need any absolute value sign. So if I write sine theta over cosine theta for tangent, and if I write 1 over cosine theta for secant, the answer becomes simply sine theta. And that is why, in principle, I can solve this integral very easily. So integral I becomes the integral sine inverse. Instead of this expression here, I put sine theta. So it becomes sine inverse of sine theta. And then instead of dx, I plug this expression in, multiplied by 2 times tangent theta, secant squared theta, d theta. But of course, we know that sine inverse of sine theta is actually theta itself. And then I bring this 2 out, so it becomes 2 integral. So let me change my color. This becomes 2 integral of theta times tangent of theta times secant squared theta d theta. Okay? Now here we can use integration by parts. What I do, I will take this one to be u and this one to be dv. Okay? So theta is equal to u, so it means that d theta is du. And I will take tangent theta secant squared theta d theta to be dv. And then this means that v is the integral of this itself, so it becomes tangent theta secant squared theta d theta. But this is a very standard integral, so what I can do, I can write secant theta here, and I can write tangent theta times another secant theta d theta. So instead of having secant theta squared, I have secant theta here and there. The reason that I did this, because now I can use the variable, I can name this one t, and you know that this becomes dt. Yes? Because the derivative of secant of theta is secant of theta times tangent of theta. So if I put this equal to t, this part becomes dt, and this integral is simply 1 over 2 t squared. So I go back to the same color, so it becomes 1 over 2 secant squared theta. Okay? Now let us go back to my integral. So my integral I that I was calculating is 2 times. And I am supposed to use the integration by parts. So u dv is equal to u times v. So it becomes u, which is this one, times dv. Sorry, u times v, which is this one, times this one. So this becomes theta times 1 over 2 secant squared theta. And then minus the integral of v times du. But what is my v? This is my v here. So I would write v, it becomes v du. Yes? And what is my du? My du is d theta. Okay, but this is a very standard integral. So if I multiply this 2 in, this 1/2 will cancel, this 1/2 will cancel. So what is left for me is theta secant squared theta minus the integral of secant squared theta d theta, but that's also a famous integral. So it is theta secant squared theta minus tangent of theta, and then I have a c at the end. Yes? So because the integral of secant theta is just tangent of theta. And then I have to rewrite everything back in terms of x. So if I make it smaller, so you see that this theta here is tangent inverse square root of x yeah, that's correct. So let me write it in this way. Instead of secant of theta secant squared. Let me write theta times 1 plus tangent squared, yes, minus tangent of theta. So instead of secant squared, I can write 1 plus tangent squared of theta. So now what happens? This is equal to, instead of theta, I can put this tangent inverse. So, and then instead of tangent squared theta, I can put x. So this becomes 1 plus x multiplied by a tangent inverse of square root of x minus, instead of tangent of theta, I can simply put the square root of x. So it becomes minus a square root of x, finally plus c. And that is the answer provided in the problem itself. Yes, that's exactly that answer. Okay, I hope that you enjoyed this problem. I will put the link to the PDF file of these notes below this video in the descriptions. Until the next video, be safe and goodbye.